Hello, this will be our second video on Laplace transformation. I'll continue making some of the other proofs that we started in the previous one. Okay, let's say that I want to prove that Laplace of sine 80 equal a over s squared plus a squared, but still here you have another hint that says that sine 80 equal e to the power of I80 minus e to the power of minus I80 over 2i. Okay, so now instead of this sine 80, I'm going to plug in this value, which is Laplace of e to the power of I80 minus e to the power of minus I80 over 2i. So I'm going to find out what's the Laplace of this value. First thing, I can take out 2i as a constant number, and I will be left with e to the power of I80 minus e to the power of minus I80. Next thing, you can distribute this Laplace for both values. Okay, once I distribute this one, I can find what's the Laplace of this value and this value by going back and reminding that Laplace of e to the power of 80 equal 1 over s minus a. So here, in case you have a coefficient for the a, which is I, this I is going to be added here. So this will be 1 over 2i, 1 over s minus I a, minus 1 over, okay, here if you have a minus, here you'll have another minus, and minus with minus will give you plus. So this is going to be 1 over s plus I a. Good. Now the next step will be making this as a lowest common denominator, and still I'm going to use here the difference between two squares. It's going to be s squared minus I squared a squared, because I times I will give you I squared and a times a will give you a squared. And here for the numerator, here you're going to have s plus ia minus s minus ia. Good. Now I'm going to make it more simpler. Please try to remember that I squared equal negative. This is an imaginary number, so here this negative is going to be changed to positive, because I squared means negative 1. So negative with negative will give you plus. So it's going to be s squared plus a squared. And here I'm going to open the bracket. Here we'll be left with s plus ia minus s plus ia. Okay, good. So now what are the things that I can cancel out here is s with negative s, and you're going to be left with 2i's over s squared plus a squared. Now you can cancel out the 2i with the half of 2i. So what will be left is a over s squared plus a squared. So we already have proved here that Laplace of sine 80 equal a over s squared plus a squared. Good. Now we're left with the last proof of this type, which is a Laplace of cosine 80. So Laplace of cosine 80 equal s over s squared plus a squared. Again, here we're going to use the hint that will make this proof simpler, that cosine that cosine at equal e to the power of iat plus e to the power of minus iat over 2. Let me make this one more clear. Alright, now I will start to prove. Instead of this Laplace cosine at, I'm going to plug in this value. So you're working for the Laplace of e to the power of iat plus e to the power of minus iat over 2. I think that by now you are already familiar with the steps I'm doing. I'm going to take the 2 out as a common factor, and I'll be left with Laplace of this. Okay, so once you reach this step, you're going to distribute this Laplace for both. Laplace of iat plus Laplace of e to the power of minus iat. Good. Don't forget that Laplace of e to the power of at equal 1 over s minus a. So here e to the power of minus iat, here if you have an I, you have an I here again, so it's going to be 1 over 2, 1 over s minus a, plus 1 over, here if you have a minus, this is going to be changed to plus, because there are going to be 2 minuses, will give us a plus ia here. Now I'm going to go for the least common denominator, which is s squared minus I squared a squared, and here s plus ia plus s minus ia. And please here don't forget that I squared means -1, so this negative is going to be changed to plus, because I squared equal -1. So it will be s squared minus with minus going to give me plus a squared. Here I'll make it simpler. Minus ia and plus ia will be cancelled out, and you're going to be left with 2s. 2s, because here you'll have s plus s, which will give you 2s. I can cancel this 2 with the half, and I'll be left with s over s squared plus a squared. So here is the proof for Laplace cosine at equal s over s squared plus a squared. Okay, I'm done with these proofs. In the next videos, I'm going to give you examples of finding a Laplace transformation for some functions.